Hello, so today we are going to solve this problem which is total decoding messages. Let's read the problem. A message containing letters A to Z is being encoded to numbers using the following mapping. A is mapped to 1, B is mapped to 2, and similarly up to Z it is mapped to 26, and you are given string digits. You have to determine the total number of ways that messages can be decoded. So let's understand the problem. So the problem is we are given digits, which is a string with digits like 1, 2, and 3, and every digit is mapped to an alphabet. Like here, 1 is mapped to 1, 2 is mapped to 1 is mapped to A, 2 is mapped to B, 3C, 4D, and up to 26 is mapped to Z. And what we need to find is the total number of ways you can decode 123 into using these characters and using these mappings. Like here, if we are having 123, right? The first way we can decode it is 1 is mapped to A, we can write it A, 2 to B, and 3 to C. This is a way, and another way could be 123 is we can take 12 together, means 1 2 together and 3 separately. So 12 is mapped to L, right? So L and 3 is C. We can decode it like this, and if we take 123 as take 1 separately and 23 together. So 1 is A and 23 would be W. So W. These are the only three ways in which we can decode 123. So we need to return 3 here. Another example is 90. Means we have given 90. So one way could be we take 9 and 0 separately. So 9 is mapped to I here. 9 is mapped to I, but 0 is mapped to nothing because the mapping is started from 1 and 0 is mapped to nothing, so we cannot decode it this way, means not we cannot take it separately. So let's take two digits at a time, 90. So if we take two digits at a time, but we have mapping till 26, right? So we can not go beyond 26. So 90 can also not be decoded to anything. So in this case we need to return 0, and if we take another case 0 5, and in this case if we take single 0, there is no mapping of 0, so we cannot single. And if we take 0 5, but in the problem it is mentioned that we cannot take 0 5, means we cannot consider 0 5 as 5 because every digit is different. That's why 0 5 can also not be decoded. So in this case also we are going to return 0. It's O, we need to return 0. So what we have observed here is the digits would be ranging from 1 to 26, right? And if there is a 0 we are encountering, then we cannot explore it, we cannot decode it. So the case here is uh, it ranges from 1 to 26. So like 123, we can take either one digit at a time or two digit at a time. because if we are going to take 3 digits and it would be something like 111 as well, then the 3 digit would be always greater than 26, right? So we need to take either 1 digit or 2 digit which is less than 26. So the first case is if it is 0. If it is 0, then we will not explore the path and we straight away return 0, means there would be no way to decode the string. And the other 2 points we need to notice, the second point is we can have a single digit, right? And third point is we can have double digit which is lesser than equal to 26, then only we can explore. So we can do this using recursion, like here if we have 123, right? If we are going to take 1 digit and first the index is 0, so from index 0, 0, 1, 2, these are 3 indexes. If we are going to take one index, so 1 would be mapped to 1, and now we are left with 23. This string we left with. And if we take 2 indexes, it would be 12. So 12 is less than 26, we can map it. So 12 is done, and now we are left with 3 only, right? So now here the index is 1, here the index is 2, because the index of 3 is 2. Now we can take here either one index or 2 index. If we are going to take one index, so 1 is already mapped, right? Now we are going to map 2, it is encoded. Now we would be left with 3. This is done, we left with 3. And if we are going to take 2 digits, then it would be 23, right? First was 1, second was 23, and now we're left with nothing, right? So from here we are going to return 1, because this is the way in which we can explore. Like first we explored 1 digit, so 1, and then we explored 2 digits, that is 23. This is one way, right? And now 1 explored, 2 explored, 3. From 3 we can have only single digit, we cannot have 2 digits. So 1 is explored, 2 explored, 3 explored. So the other way is 1 separate, 2 separate, 3 separate, right? And in the second case where we explored two digits at first and we have 3 here, so 3 we can explore and we can decode it. We can have only a single digit, that is 3. So 1, 2 and 3. So this is going to return 1, this is going to return 1, and this is going to return 1. So 1 would be returned here, 1 plus 1 plus 1. So here let's see, 1 plus 1, 2, this would be returned here 2, right? And 1 is returned here, 1 and 1. So 2 plus 1, that is 3. And the last was 1, 2 and 3. So 1, 2 and 3. These are the ways. So this is how we are going to solve it using recursion. But what we here can see is at last here we left with only 3, and here also we left with only 3. So there are the overlapping subproblems, so we can store the overlapping subproblems in a DP array and store that if we are at index 3, we reached at index 2, sorry, if we have reached index 2 and we got our answer is 1, we are not going to explore again 3. Like if here we encountered 3, we directly return 1 from here. So that's how we are going to use DP in our solution. So let's code it up. We are going to code our solution, and as we have discussed, we are going to use dynamic programming for solving this code, but let's first write the code with recursion. So we would have a method which is end solve, and what we are going to pass here is int. The first parameter should be index, it is index, and other parameter would be string digits, right? And the base case would be if the whole string is traversed. So if index is greater than equal to digits dot length, right? If the whole string is traversed, we are going to return 1. And as we have discussed, if we encounter 0, we are not going to explore the string. So if digits at index is equal to 0, if it's the case, we are going to return 0 right away. And now we discussed two cases. Either we can take a single digit or two digit. So for the first time, if we are taking one digit, int 1, if it's the case, we're going to take it and explore the further indexes. So we're going to call the solve function with index plus 1 and digits, right? And in which case we are going to explore the two digits when the two digits is number is lesser than equal to 26, right? So if first condition would be if index plus 1 is less than digits dot length. Why? Because if index plus 1 is less than digits dot length, then only we can take the two digit number, right? And the other condition is the value of the two digit is lesser than equal to 26. So string stoi, this is the function, built-in function to know that what is the value of the string in int. So stoi of digits dot substring, from where we are calculating the substring from the index, and the length of the substring should be 2, right? So stoi of digits dot substring index and 2, it should be less than equal to 26. Then only we are going to call it for two digits. So if we already declare the 2 as 0, and if the condition satisfies, then we are going to call it for two digits as well. So solve index plus 2, because we are going to get two digits, that's why we are jumping to the second index. We are incrementing the two indexes and we are passing digits, right? And at last we are going to return 1 and 2, 1 plus 2, because we are exploring both ways and adding the count of it. So let's return here the solve method with index starting from 0 and passing the digits. Let's see if it's working or not. And yeah, it is working, but we are not going to submit it as we need to write the DP code as well. So if int n is digits dot length, right, we are going to declare the vector of dp. Its length should be n and initialized it with -1, and we are going to pass dp here and pass dp here as well. Vector of int of dp, we are going to pass it, and we are also going to pass it when we are calling the function in itself. So dp we are passing here, dp we are passing here, and if the dp of index is not equal to -1, then we are going to return the dp right away, dp of index, and when we are going to return it, we are storing the dp index. Now if we run the code and see if it's working, yeah, it is working. Let's submit the code, and yeah, so it is working. So thank you so much. Bye.